All right, welcome. We're now going to go over implicit differentiation. So implicit differentiation is taking derivatives of implicit function. Well, what does that mean? Well, okay, let me be a little more clear by giving an example. Up to now, we've been dealing with explicit functions or equations given in explicit form. Hey, so we can have like maybe y equals 1 over x, but now we're going to have to work with equations given in x or implicit form. So we may have something like x times y equals 1. Now we like this form because we're given y in terms of x. So we're always very happy to work with these because it's not going to give us any extra work. That's a face. This gets us a little, suspicious. This is a square face because that's what happens when you get suspicious. So think of it as like those friends, or maybe those friends that are kind of like always like sketchy. Like an implicit function is like a sketchy friend and maybe like is like telling you like, oh yeah, I can make it, but I'm not sure. Let me just check with my friends' plans and let me go get back to you. And you're like, well, are you gonna be free to like come hang out after school? Yeah. But let me check something with my buddies, mom, brothers, sister, and then they never really like give you a straight answer. They're always like hidden, and like hidden like means being like not straightforward. This is straightforward. Y equals 1 over x. This is like that friend that says, hey man, you want to hang out after school? Yes, I'll be there. 3:05 on the dot. Right by the tree? Yes, by the tree. Cool. So y equals 1 over x. Y is given straight up in terms of x, like the function way. Implicit, the y is buried with some crowd, and it's like not very clear. And the reason we will have to deal with these is because you're going to have functions which aren't technically going to be like functions, but we care about finding the derivative. We don't really care necessarily always about the graph being a function of x. We care about being able to describe where on the graph it's changing by this amount. We want to know the derivative. The derivative is how the graph is changing at certain points. So even if it's not a function of x, like we can still take the derivative because we can figure out how it's changing. But this is going to require a little bit more like calculation and math, math skills. So let's look at, let's go through an example. So example 1. So let's start with, let's say you want to find the derivative of this thing. Y cubed plus y squared minus 5y minus x squared equals -4. Now, we can't just like it's not easy to put y isolated as a function of x, but we can still take the derivative using this strategy. Whenever we take the derivative of y, we're going to multiply by dy dx. So we use the same power rule here, 3y squared, and then we go dy dx plus here 2y, take the derivative, dy dx minus 5 times 1 times dy dx minus the x squared. We just keep it straight up like we've been doing. We don't need to multiply by dy dx, and this is actually not what I meant to write. I actually just was practicing my handwriting, so forget about that. We take the derivative straight up. So the derivative of x squared is just 2x. Oh no, you can't see me for a few seconds, but it's okay, I'm still here. See? And we take the derivative of -4, which is 0. And now we treat the dy dx as if it's like a term, or if it's like as if it's like we're solving for like a variable. It's not technically that. It's not even technically a fraction, but you can treat it by those similar properties. So don't overthink it. Don't even like think about what I was saying. Sometimes it can sound confusing when I keep on talking about it. Just think of it as factoring dy dx out of this group. So we would have dy dx times 3y squared plus 2y minus 5. And let's add 2x to the right side equals 2x. And then we just divide by this. This whole group. And you get this. We get dy dx is 2x over 3y squared plus 2y minus 5. So that's your derivative. See, pretty simple looking, right? No, yeah, it's usually going to give you like a messy looking answer. But remember, we just want to find an equation that will tell us how we can find the rate of change on the graph. So it would make sense to like, let's find a point that we want to find the derivative at. So what example did I do here? So let's find 2, 0. So let's add this. Find dy dx at 2, 0. Now, I'm gonna show you what this graph looks like. So don't get scared. Okay, it's all right, because it's just math. Sometimes I get scared, so I gotta concentrate. So it's gonna be like, it's gonna look like some witchcraft like spell. It looks like a bong, actually. I mean, not that I would know, but 2, 0 is actually right here. So this whole thing is this. And yeah, I knew this off the top of my head because that's what I do. No, actually I didn't. I used a textbook to help me because I have better things to do than calculate this. And let me label the axes. Y, X. Okay, so see, it's not going to be a function of x because it violates the vertical line test, and it's not going to have one y value for each x value, but we care about finding the slope at this point. So if we wanted to find the slope at this point, we have our equation for the slope. See? So we plug in 2, 0 for x and y. So at 2, 0, hopefully I can, I hate hunching down, but you gotta do what you gotta do. So dy 2 times 2, 4, 2, 3, 0, 0, 0, negative 5. Negative 4/5. So it's saying the slope at this point is negative 4/5. I'm actually a better marker, but like, actually, does purple work? So negative 4/5. So again, looking at the tangent line, yeah, it looks like negative 4/5 exactly. I mean, not exactly because of, the whiteboard is crooked. But anyways, that's the idea. The idea is to find an equation for the derivative so that we can just plug in values on the graph and just know what the slopes are. So it's not all about, having functions, even though they're very important. Okay. Well, now that we got that down, let's do some more examples, yeah? want to erase that, but I have to. I have no choice. Let's see what else I can do. I can do a lot of stuff. So let's see. Let's step it up with a fun one. So got it. Got a good one for you guys. Let me take the whole whiteboard. So this is a good time to if your parents are like, you know, kind of like keep it, or like if you're like grounded, or your parents are like, you know, paranoid about you not studying, you know, this is gonna be a good time to kind of let them see what you're doing, and they're probably gonna get scared because they're gonna see such a complex looking calculus problem that they're never gonna bug you again. So calculus has power. Use the power. And I'm rambling. So anyways, example 2. So find dy dx at 3, 1 of 3y, nope. 3 times x squared plus y squared equals 100xy. All right, so let me first show you what the graph looks like, because then we can get some idea of what we're doing, and we don't want to lose sight of the concept here. So here we actually have this cool graph called a lemniscate. Lemniscate, see? So if you want to impress like some girl or some guy, like, you know, ask them to homecoming, or, you know, tell them, hey, want to see what I can do? I can do it. You want to be my lemniscate? And yes, I'm kind of a geek when it comes to this, because I'm trying to entertain myself. But it's basically like this infinity diagonal looking thing. And we're saying at 3, 1, which is about right here. So we're trying to find the slope of the tangent line of this right here. Slope? What's the slope here? And this is a lemniscate. Lemniscate. I think that's how you pronounce it. Never bothered checking, but I trust my instincts. Okay, so here we go. I would probably expand this first. So I'm going to go and do that before differentiating. So we're going to go this x squared times x squared plus y squared times x squared plus y squared. And I'm going to show all the steps, because I know that sometimes you may forget these basic things, or just sometimes it's been a while. So I'm a high school teacher, so I know that this happens. So distributing, so we x to the 4th plus x squared y squared plus 2x squared y squared plus y to the 4th is 100xy. And I'm actually going to go like over here, because I know what's going to happen. It's going to be very long. So we'll go 3x to the 4th plus 6x squared y squared plus 3y to the 4th. And I'm going to subtract xy. So minus 100xy equals 0. Now, differentiating this. So we got to be sure we do the y part correctly. So here we just use the power rule. So I'm differentiating now. So changing, I don't know what that is. So power rule, 12x to the third. Here we got to use the product rule. Because we have an x squared and a y squared. Let me make that a little bit red. So we're going to go plus 6 times, take the derivative of x squared, which is 2x, leave the y squared as is. Whoa. Plus, this time leave the x squared as is, take the derivative of y squared, 2y, and then multiply by dy dx. Because again, when you take the derivative of a y term, multiply by dy dx. This 6 closes the parentheses. Here we got another one. Take the derivative of 3y to the fourth using power rule, 12y cubed, multiply by dy dx. Dy dx. Minus, oh no, we're going crooked. I'm gonna stop going crooked. Minus 100. X, leave the x, or take the derivative of x because we have another product. So 1 times y plus, keep the x as x, take the derivative of y, which is 1, then multiply by dy dx. Oh, kind of blocking it, sorry about that. Let me put that in parentheses, 1. I never know if it's better to look a 1 have looking like this or just the parentheses. Whatever. Okay, we're good there. Product rule equals 0. The derivative is 0, 0. Okay, now we do some algebra, break it down or factor out this dy dx as much as we can. And yeah, let me do this all. Let me kind of like not skip a step so I don't mess up somewhere. 12x cubed plus 12x y squared plus 6 or plus 6 times 2 plus 12 x squared y dy dx. Right, yeah. Plus 12y cubed dy dx. Minus 100y minus 100. Whoa, I'm going down. For now. Time minus 100x times dy dx equals 0. Hey guys. This is only crooked because of the gravity. Gravity's pulling. I have extra gravity in this room. Don't try to think about it because it doesn't confuse you. Now, factor out the dy dx for these 3 terms. Bring everything else to the right. So let's do this. That's good. Good way for it. It's a good boy. Dy dx, factoring that out from 12x squared y plus 12y cubed. This minus 100x. Come on. Okay. Equals. So I took care of that. I took care of this. I took care of that. I'm going to subtract this. So subtract 12x cubed. Subtract this. Minus 12xy squared. Yes, I'm walking on my knees. You have to do what you got to do the math. And add 100x or add 100y to the right. Okay. Okay. Now we just divide by this. 12x squared y plus 12y cubed minus 100x. And go over here. 12x squared y plus 12 y cubed minus 100x. Right? Hey guys. Yes, I think so. Oh man, I really hope I didn't screw up. Okay, I'm gonna go back over here now. dy dx equals this. Negative 12x cubed minus 12xy squared plus 100 y over 12x squared plus 12 y cubed minus 100x. And this should be your equation for dy dx. And you can actually simplify this a little bit, factoring out a 4. But let's not mess with it. Okay, we're good. Hey, I forgot it's Andrew's Odie. Odie. Come on, Odie. It's lazy. He had Panda Express earlier on. He's gonna take a nap. Okay, so we're not done yet because we're trying to find the slope at 3, 1. So we just plug in 3, 1 into here, and then we'll get our answer. So where should I go? Okay, I'm gonna go over here. Slope equals, so plug in 3 for x and the 1 for the y. 3 and the 1 for the y. I actually have a little bit more room, so I'm gonna move that slope to the left a little bit. Slope equals, okay, so negative 12 times 3 times 3 times 3. So negative 12, 3, 9, 27, right? Minus 12 times 3 times 1. Here, 12 times 3 times 1 plus 100 times 1. Plus 100. So plus this 100. Can I erase this arrow? Because it's in the way. Plus 100 times 1. Yeah. And then 12 times 9 plus 12 times 1 minus 300. 12 times 9 minus 12, or plus 12 times 1 minus 100. Minus 100. No, minus 300. Minus 100 times 3. Okay, here we go. Moment of truth. All right, come on, I gotta use my special calculator. Negative 12 times 27 minus 36 plus 100. 260, 12 times 9. It's 12. So 260 over 180. All right. So we will get negative 260 over negative 180, which will be, if you do a decimal, it'll be 1.44 repeating. But it's all good. It'll just be, what, 13 over 9? Those zeros go away. 2, 13. Yep. Same shit. The same thing. All right. Now we can rest for a few minutes before we go to the next one. So again, this is what this slope is. It's purple now. Slope is, take away the question mark, about 1.44. Because again, that's what we're trying to do. That's what dy dx is. It's an expression for the tangent line on the graph at various points. And it makes sense because it's positive. And, you know, that looks, according to my math vision, that's about 1.44. I'm joking, of course. Well, I mean, I'm not joking. That's what it is. But I didn't draw it perfectly because of the gravity. Anyways, there you go. This is a good example to help you really get this stuff down. I like doing the hard examples because the rest will seem easier. But don't worry, there are some more harder ones I'm going to go through. But absorb that, and I'm going to go through some more examples in the other videos. So keep an eye out for those, and let me know if you have any questions. And of course, subscribe and tell me what you think. And I'll see you guys next time. Bye.